Thank you very much to the Brisbane Mining Club for the opportunity to speak again. This is my third presentation to the Mining Club, and going back through my records, I note that the last time was in 2011, and prior to that 2007. So there's a fair bit of water under the bridge for me and many others in the room since then, so it's a really good opportunity to speak with you, particularly freed from some of the corporate constraints that I was previously under in talking on behalf of Extrata. So today I'll be talking to you from a personal perspective, but also, as Alice mentioned, from a perspective which I hope encapsulates what the University of Queensland and Sustainable Minerals Institute are driving towards in looking at the issue of complex ore bodies and how we should be dealing with those. So what I'd like to cover today is an explanation, at least my explanation of what complex ore bodies are in the definition that seems to be emerging in recent years. How we can address those, a proper understanding of them, so that we can hopefully come towards some common solution to finally unlocking the huge value potential that these ore bodies have. And I'll be dealing about this in the copper space. I'll unashamedly talk about copper during my presentation. That's my professional background, and I maintain a strong interest in the copper industry. But there's no doubt that these ore bodies can present enormous value opportunities, not just for the companies, but shared value with communities and governments and communities around the world. So I'll start with a chart which I think is well understood in the mining industry, and I can see the eyes rolling of many in the audience here. You've seen charts like this before, and I share a healthy cynicism for this type of theoretical supply-demand chart that we see. There, as we know, there has always been a copper supply gap into the future, and I'm certain that when I gave my presentation here 8 years ago, I would have wheeled out a supply-demand chart very similar to this one. Perhaps the x-axis had changed somewhat. But there are a couple of important points that I'd like to make in relation to this chart. Firstly, the global copper production has indeed increased in recent years, and so we're now talking about production meeting a global copper demand of something in the order of 22 or 23 million tonnes of copper globally. And that has been increasing by around 3% per year in recent years, and that is forecast to accelerate a little, to be increasing by around 4% per annum in future years. What that means is that it will require something like 800,000 tonnes of new net copper metal to satisfy the growing demand. The second key point that I'd like to make is that the demand increase has historically always been filled by variations in demand itself, by mine expansions and extensions, and by discovering and developing ore bodies. So if you have a look at this chart and understand that the rate of growth is increasing, it may be a time now to be saying that we are indeed running out of available copper deposits to supply this seemingly insatiable demand for copper, which as we all know, has got very strong uses in a world where we're looking for sustainable energy. Basically, to meet the sustainability needs of society into the future, copper will play a very important part. But when you have a look at another chart, which is a contained copper in undeveloped mineral resources, the the answer to that first question was a definite no. There's a huge tonnage of additional potential mineral resources that might be converted to reserves and delivered as copper supply to satisfy that demand. So this is, just to be clear on this figure, this is more than 1 billion tonnes of copper contained in mineral resources which is known, currently known around the world. So even factoring down for conversion of resources to reserves, you might think that the contained copper in resources to reserves might equate to several decades of supply in the copper market. Well, here's where it starts to get interesting, the story about these, because this chart shows the distribution of these deposits, and as you can see, quite a number of them are located in what could be described as challenging parts of the world. Secondly, most of these deposits have very low grades. If you see, this is the majority of these deposits have grades of less than 0.7% copper equivalents, which includes the byproduct credits in addition to the copper. And thirdly, 95% of these deposits were discovered 10 or more years ago, and most of them were discovered more than 20 years ago. So all is perhaps not quite as it seems. Most of these undeveloped copper deposits have issues that need to be better understood. What we do know, and those of us who've been in the industry for quite a number of years, is that project economics are certainly a factor, but historically, as we know, the industry has been pretty good at solving technological problems and addressing cost issues with ongoing cost efficiencies. And this has been done through a combination of technological breakthroughs, increasing scale both of ore bodies themselves and the mining and processing methods, increasing automation and just continuous cost efficiency improvements. But while it's probable that we'll continue to see cost improvements in the industry, there may be a limit to how much further we can go to drive down the economics of known ore bodies. So let me introduce to you the world of complex ore bodies. And the reason I'd like to do this is I believe that with a comprehensive understanding of complex ore bodies and the huge challenges that they actually present, we can approach them in a different manner towards value realisation. In other words, to solve the conundrum. The supply of copper to meet the world's increasing demand for this key element of our sustainable future will continue to be met by production and expansions of existing mines, new discoveries, and importantly, recycling of this metal. But importantly, will also need to be met by the development of those copper deposits that are very complex and challenging by virtue of a range of often interrelated factors. Historically, this has been only really viewed through the lens of ore grade or mineralogical complexity. However, we know that many of the grade and technological issues are surmountable, as showed in the previous chart, and they actually pale against the substantial issues such as serious environmental concerns, competition for water, social resistance or outright conflict, political risks, tailings disposal, among many other factors. So I will call this much broader range of factors, which still includes, by the way, the grade and variability issues, sustainability issues or sustainability risks, and will suggest that they need to be considered in parallel with traditional drivers of ore body evaluation. Okay, so this is where it gets really interesting. but perhaps not so much in an informal post-lunch session like this one at the Brisbane Mining Club. But please indulge me for a few minutes, because hopefully it'll be worth it as we progress through it. So in the mining industry, we have traditionally drawn upon databases such as the SMP database and the in-house company information to gain information about ore bodies. The ore grade, resource reserve, conversion factors, met performance, project economics, and so on. But recent work, which has been led by Professor Rick Valenta, who is with us somewhere today, perhaps over in this area, Rick, and his team is radically expanding this knowledge base by tapping into publicly available, highly regarded, detailed data sets to overlay on our known industry information, to look at the overall risk profiles from a more comprehensive perspective. We're talking about data sets from, for example, the World Resources Institute, from Nature, from the Food and Agriculture Organisation, the World Bank, United Nations, and so on. And when you overlay these geographically focused data sets over our known mining industry and company data sets, some fascinating information emerges. Take, for example, an overlay of global water risks from the Aqueduct database of the World Resources Institute over the known undeveloped copper deposits. That is the same chart that I showed you earlier. This gives indicative risks from low to extremely high risks, as shown in the colour coding. Or another example is an overlay of a combination of public databases on terrain, flood incidents and seismicity over the known copper deposits to give an indicative tailings risk rating, in this case with light blue representing low risk to dark blue as a high risk. And this can be done for a range of what we call sustainability-related factors for any deposit. A key point here is that these would be done at the same early stage of project evaluation as you would do a grade evaluation, for example. You would look at and assess the validity of these factors early enough to be able to determine appropriate resourcing and the focus areas in your project assessments. Another critical point that becomes very clear when you start to assess copper projects in this way is that it is not all about the copper price. The vast majority of undeveloped copper projects have significant risks which are quite independent of the copper price. This is a key reason that most undeveloped copper projects remain undeveloped decades after their discovery, and why we refer to them as complex ore bodies. So, what can we do with this information? Well, a team at UQ, at SMI, under Rick's leadership, has prepared risk tables showing the outcomes of these risk ratings into what we would call a risk table. This particular table shows the sustainability risks, colour-coded from low risk in green to high risk in red, for the 40 largest undeveloped copper projects in the world. And I should point out that this collectively represents more than 500 million tonnes of contained copper metal. A quick glance at the table shows that most of these deposits would comfortably fit within our complex ore bodies definition and classification. And for the purpose of this presentation, I've selected 6 of these projects that I have had historically or continue to have direct involvement in, so that I can spend a few minutes talking about some of them that have been or are being evaluated. And I can hear a few chuckles in the crowd from other people who have been involved in some of these projects as well. By the way, all of them would definitely fit the bill as complex ore bodies, as you'll see with a few of them. So these are the selected copper projects. They were selected by me. and they've got some interesting technical characteristics. All are very large tonnages. You can see that all are between 2 and 4 billion tonnes of mineralisation. All have huge contained metal in resources, between 7 and 15 million tonnes of contained copper each, and up to 60 million ounces in contained gold each. And all have had very large capex price tags of between $2.5 and up to $8 billion US. And all were discovered decades ago. And this is the same list of projects presented in the, I'll call it the SMI risk table, and you can see there's a lot of yellow, orange and red colour in there, which is not necessarily a good thing. So I'd like to spend a few minutes focused on 3 of these projects, Tampakan, Nuevo Unión and Frida River. But I'll just give you some landscape snacks to give us all a break from the detail for a couple of minutes. So this is El Pachón, which is located at around 4,000 metres above sea level in the Andes in the province of San Juan in Argentina, around 5 kilometres from the border with Chile, which has had a full feasibility study done on it, by the way. Agua Rica, which is located, this is probably a summer shot of Agua Rica, by the way. This is located in the province of Catamarca in northwest Argentina. It's at a slightly lower elevation of around 3,500 metres, and it has a distinct advantage of being only 40 kilometres in a straight line from Minera Alumbrera, but that's through a couple of mountains to get there. Agua Rica is another very interesting project which has had pre-feasibility into feasibility study work done on it. And Norte Abierto is a really interesting project which has combined 2 massive projects, the Cerro Casale project and the Caspiche deposit. It's in the Atacama region of Chile, and depending on the deposit that you're looking at, it's located between 3,000 and 5,100 metres above sea level. Definitely work in progress, but it has massive volumes of gold and also copper. So I'll now spend a few minutes talking about the Tampakan project, its potential, its evaluation to date, without getting into too much detail, and the possible further risk management approach that could be taken with Tampakan. So let's get back into it. So Tampakan is still located in Mindanao, which is in the southern part of the Philippines, and it's been quite a notorious place geographically and from a socio-political point of view over the decades. It's a huge deposit, as I showed on a previous slide, of nearly 3 billion tonnes with about 15 million tonnes of contained copper and 18 million ounces of gold. Capital cost estimated around 7 or 8 years ago was just under $6 billion. Production levels that were estimated through the feasibility study of this project were 370,000 tonnes of copper and 360,000 ounces of gold over close to a 20-year mine life, including about 450,000 tonnes of copper in the early years. And depending on the price scenarios that you'd like to put in there, you've got a project there that from an operating cash flow point of view could generate up to $2 billion per annum of operating cash flow. So very substantial project and huge economics in terms of revenue. If you want having a look at the project benefits that were being talked about several years ago and indeed still are, you can see the implied benefits and direct benefits there that the project had in terms of employment opportunities with 10,000 jobs in construction, ongoing employment opportunities, direct employment of 2,000 people, very substantial local royalties and local taxes and national taxes, and incredible influence and positive influence to both the regional GDP for the project, and the fact that this project on its own would have added around 1% to the GDP of the entire nation of the Philippines. So massive benefits in terms of social benefits in those aspects and financial benefits. So it seemingly represented an overwhelmingly compelling case for development. However, if you look at it from another backdrop, which is the same information that I showed you earlier on, you can see that on many sustainability measures, Tampakan has significant challenges and risks that simply have to be overcome, all of which really have to be overcome to allow the ultimate development. It's your classic complex ore body, whether we like it or not, and nearly a decade ago, Pete Forrestal, who is also with us today over there, thank you Pete, and his project development team worked their way through a number of these risks as part of the pre-feasibility and feasibility study into this project. I'll just touch on a couple of them for you, and the water risk management was a key area of focus of the feasibility study, because it required a full evaluation of water risks, regional and local groundwater models, and a water management plan which could definitively show that any risks associated to water within the project or to surrounding communities and the environment were effectively mitigated. Similarly, with tailings risk management, some of these charts that you'll see here actually were drawn from some of the public database sets, but you can see here in terms of tailings risk management, it included a full evaluation of the seismic risks in the area, landslide risks and flooding risks, to enable the management team to come up from an engineering point of view with innovative tailings storage management solutions. So trying to work through all those factors there to come up with an effective solution, effectively to mitigate the risk that we're indicating there. And the local community risk management was a huge issue. The project site is approximately 15 kilometres long by about 5 kilometres across. Is an impact, direct potential impact on around 10,000 people who live in that project area. And so there was a requirement to have very extensive community consultations to try and reach some common ground on measures that could be taken that were acceptable to the community, and also to allow the project to progress. The land pressure risks management, which is another element that has been identified, required the company to work closely with the communities and the authorities to identify how to reconcile the competing land use activities, and also to work through a relocation plan for more than 4,000 people who are living in 900 households in and around the project area. So these are significant risks requiring an enormous effort to try and come to some agreement. If you put this into, let's call it a modern context of complex ore bodies risk management, the ultimate objective here would be to satisfy all stakeholders that all of the relevant sustainability risks had been adequately mitigated. And diagrammatically, this is represented by demonstrating that the material risks had been successfully moved from the top right sector towards the bottom left sector through coordinated multidisciplined efforts. And despite the enormous efforts of the teams involved at the time and the expenditure of in the order of $200 million US, Tampakan remains a work in progress. But what it still does have, and all of us who have been worked on the project know, it has the potential is for enormous shared benefits and shared value if we can work through all of these risks and identify opportunities here which will make the project a reality. Turning more briefly to Nueva Unión, this is also in the Atacama region of Chile. With Norte Abierto. It's a fascinating project from my perspective because it is actually currently being transformed from two quite independent projects that had very challenging economics, each in their own right, and their own particular community, environmental, infrastructure, and permitting issues, into a combined project that's looking increasingly likely to be developed. But it certainly had and still has its challenges to overcome, as indicated by this risk chart. Not quite as extensive in the set of risks as Tampakan, but still equally demanding in a number of those. The project is, by the way, close to the coast, as was Tampakan, but this is only 120 to 160 kilometres from the coast, but the whole project area and infrastructure has to go from sea level up to 4,000 metres above sea level and accommodate that with the infrastructure. So topography is definitely an issue. But a big step forward on this project came in 2015 when Goldcorp, who we as Xstrata Copper sold to we sold the El Morro project to, and Teck, who had evaluated the Relincho project nearby, decided to form a 50-50 joint venture. So you can see what the merger has resulted in terms of rationalisation of infrastructure. And it's quite remarkable. The original projects, which were relatively close to each other, had 2 mines, 2 processing plants, 2 tailing storage facilities, 2 pipelines, separate power lines, 2 port outlets and 2 desalination plants, which it seems nonsensical when you look at it at face value, but that's the way they were being assessed. Now, of course, if you bring the projects together, you not only combine the resource base, so from 500 million tonnes and 1.5 billion, you now have 2 billion tonnes of resources to play with between the 2 pits. You have 1 processing facility down at the lower of the 2 sites. You have 1 set of infrastructure through to the coast and 1 desal plant. So intuitively that makes much more sense, and obviously in the total capital cost it makes it much more reasonable in terms of mitigating that infrastructure risk. And the other thing I just wanted to point out on Nueva Unión is that each one of these little dots here and the words actually indicates a community group that would be affected by the development of the Nueva Unión project, which goes right through the Huasco Valley. The project actually takes from the headwaters of in the Andes down to the port, the entire Huasco Valley. And so the valley communities are obviously keenly interested in what the project will mean for them in terms of environmental impacts, social impacts, and there's more than 50 community groups that are currently actively and positively engaged in this process. The important advantage that the project now has is that the project leadership is talking with one voice to the community, and there's one set of discussions going on, and the community is starting to understand the project and being able to positively influence the project outcomes. So it's in the same way that we did with Tampakan, you can show all of those risks on a risk matrix overview. Again, the approach to be thinking about is that all of these need to be managed in parallel to drive towards hopefully a solution which can bear fruit for all of the stakeholders. And an even briefer evaluation on the third of these for Frida River, because I realise that I'm approaching the end of the time that you'll allow me up here for. So this is the Freda River. This is a picture of the Freda River project, which is in the West Sepik and East Sepik provinces in PNG. Fascinating project. This is a project, again, a classic example of complex ore bodies. Quite a number of people in this room have been working on this off and on for decades. Again, have a look at the risk assessment. These are, by the way, indicative risks from the database, which would need to be verified, but you can see that these very much a complex ore body by that definition. The sustainability risk overlay does tell the story of the real challenges that this project has had over the years, but it's one of these projects that's sufficiently tantalising that people continue to do significant work on it, and the complex ore bodies tag does really fit very well. I think one of the fascinating things about this particular project, and the approach being taken by the current project proponents, is that this project is now being presented as part of a much larger nation-building project endorsed by the national government, which would allow a development pathway for the project, but alongside the parallel development of major hydro power generation and distribution projects, port facilities and major infrastructure that would open up the entire region for social and economic development. In other words, it's being presented really as an opportunity, not just for the company, but for the entire region and other third-party investors to invest in a whole range of projects, including on the top left of this diagram, you can see the copper gold project itself, something in the order of $3 billion capital investment. The hydroelectrical project, which is in the order of 500 megawatt hydro project, which is being put forward, which is a project which could, on its own, deliver 50% of PNG's total power demand, expected power demand by 2030, and hundreds of millions of dollars in the infrastructure projects, both the port and road facilities, but also the power grid projects. So I think that's a really interesting approach to be taking, because it does broaden the debate out, and this type of project will never go ahead unless you actually get that level of support. So similarly with Freda River, that's the type of approach that hopefully will yield some results in years to come. So just a final couple of comments, if I could, please, and by way of thanks to SMI and the SMI team on this, is that this is actually, you can see that this is one of the key strategic programs that SMI is running. It brings together expertise within the university that exists in key discipline areas, represented not just by the research centres within SMI, but other parts of the university, and the level of engagement with companies that's starting to emerge in this particular project is evident when you have a look at the diagram, which starts to tease out some of the individual projects within that overall program. And these are not projects invented by academics at the universities. These are projects that are actually developed in close consultation with company representatives and the sponsors of these projects, together with the academics who come up with these very meaningful projects. And there's a good understanding within the project and program teams that not one of these projects could actually be done independently of the others. There's all this interrelationship that has to occur for this to feed together into the overall outcomes. It does actually, I think, lead towards this approach, which is taking advantage of a unique capability and range of skills that organisation of SMI does present. So thank you very much, everyone. My sincere thanks to Rick again, and to Alice Clark, to Pete Forrestal for assisting in the preparation of the presentation, and for doing some reality checks on some of the assertions that I've made, and obviously to the Brisbane Mining Club for the opportunity to have the conversation with you this afternoon. Thanks very much.
Charlie, thank you for a fantastic talk. I'm opening the floor to questions. There's a roving mic, so if you could stick your hand up proudly, that would be appreciated, and just identify yourself when you take the microphone. Any questions, please? Thank you.
Oh, Charlie, I think you know who I am, Neil O'Connor. Given all the complexities and the situation, the demand requirements, where's the world at with substitution at the moment?
Yeah, thanks, Neil. That's a good question, because that's always, in fact, that's been always the risk of presenting a supply gap chart in the copper industry. People then look for where they should substitute copper for, so that they can actually help to replace copper with others. I think that the fact that the copper metal and the copper market is relatively depressed from a pricing point of view at the moment is helpful to the industry in some respects. The traditional substitutes of in the power industry of aluminium can't really make too much of an inroad into copper. Copper is much more accepted with the regulators and things like wiring and house distribution in electric cars. It does have characteristics that are very give it strong advantages over substitution. I think there'll always be substitution in the IT space there, but the growing demand for copper in renewable energy far outweighs some of the substitution that is naturally occurring. But the figures that come out of the copper institutes generally make some assumptions about ongoing substitution of copper for other metals or substances.
Tom Hunter, consultant. Congratulations on the thrust of your talk. I just wanted to refer to the Cobre Panama project, which is now in production at a low point in the copper price cycle and developed by an Australian-based team, and I think would qualify as a complex project. What would you think is the reason that has been such a success?
Tom, thank you for that. I think Cobre Panama is one of the few projects that has been developed in recent years, and as I understand it is ramping up quite nicely. Had significant capital commitments and put a strain on the company, but it's certainly going through the ramp-up stage at the moment. And I see some similarities actually between that and the Las Bambas project in Peru that I was associated with, in that indeed there were quite a number of issues that had to be dealt with, very complex issues that had to be dealt with, but there was a very focused effort, I think, from the management team, from what I understand, Tom, which enabled issues, particularly relating to community relations, the social issues and environmental issues, to be picked up at a very early stage of the project and dealt with in an appropriate manner, and not being done too late in the project evaluation and development. I'd be interested in your perspective on that, but that's how I see it, definitely, is that there seemed to be a particular focus on that by a company that was, in a sense, betting the farm on a major project like that. It had to work for the company, and so they put all of the resources behind, all their own resources behind it, and made sure that they were conducting good engagement with communities and other stakeholders from a very early stage, which is a key to the success. But if you have any other thoughts on that to share, I'd be really appreciative as well.
I was pretty involved when I was with Utatech, and we were supplying all the equipment. But I think what really helped them was they took over from rather dysfunctional EPCM approach and a very dysfunctional owner who was developing the project as an outsider, sort of imposing his will on everyone. And they sort of took a year or two to work out how it should be done, and then did it totally differently.
Yeah. Thank you for those comments. I do think that in the further evaluation of complex ore bodies, we need to identify big projects which well and truly fit the category of complex ore bodies, and look at what's been done well there, because that can help to provide solutions to the ones that are still being evaluated. Thank you.
Okay. Stand up. No point being shy.
Albert Cabrejo from Ground Prop. Thank you very much for the talk. One question. Would you make some extra comments on what are the risks on tailings dams? That was one of the risks on the different projects. Could you elaborate a little bit more on that?
Yeah, I'll elaborate just to a point, because you're opening up a pretty big topic here. And as I think most people know, with some tragic incidents that have occurred in recent years with tailings dam failures in Brazil, but in other countries as well. It has put the spotlight on tailings dam management, but also construction and the various factors that should go into the design of storage of tailings and also the ongoing management of them. I think the crucial point is to make sure that there's a very good understanding of the setting, the geological, topographic setting that you're in, the propensity of the area to suffer inundations or the rainfall and other factors, seismicity, whether in fact you should go to thickeners or even dry stacked tailings as a result of your own risk mitigation steps. There's a lot of engineering that needs to go into that, but an understanding of what expectations are in the local area, I think, is an important factor as well. So I think it's been given appropriate profile in the last couple of years, and I do think that it's incumbent on all companies to reassess what they're doing with the current storage facilities that they've got and how they would deal with that into the future. There's a whole spectrum of ways that you should go, and I think this still needs to be looked at on a case-by-case basis, and not have too much over-regulation determining how tailings should be stored and managed on any particular site. Thank you.
Any other questions or comments? Now's your chance. Stand up. Everyone's being shy. Over to you, Alice.
Thanks. Charlie, thank you so much for a fantastic talk and a great presentation again. It lived up to all of our expectations. We have a small gift for you. It's traditional here.
Oh, thank you very much. Thank you.
You have to show everyone.
Thank you, everyone. Thank you very much.
Well,
I can say it's actually slightly more flattering than the last one that I received, and that's saying something. Thank you.
Please join me again in thanking Charlie Sartain.